Okay, so let's touch upon the innovation for concept generation. Yeah, so certainly concept generation is iterative, and innovation is key for concept generation, right? So innovation and concept generation is kind of hand in hand, and it's also important for you as a design engineer to understand what are the various levels of innovation, right? Say for example, we have a matrix. On x-axis we have technology, and on y-axis you have market. If the technology is less, yeah, and if the market is also pretty much less, yeah, say for example there we are in the area of incremental innovation. Okay, so incremental innovation can also be thought as a delta innovation. So this is a place where you do a small increment or small delta for the product, and then you innovate. You take any product and you kind of add this particular function, some value added function. Okay, it becomes an incremental innovation. Okay, and then we talk about disruptive innovation. Disruptive innovation is where your product increment is not the delta, or it's the small portion. You need huge change in the technology. Yeah, you need high advanced technology, but your market is less, or your market is small. Okay, for example, hydrogen fueled vehicle or a fuel cell vehicle. Okay, this technology, of course, it's very complex. As we are talking now in 2022, this technology, okay, it's complex, and the acceptance or the market at this point of time today, it's not so much. So today the pull is in the electric vehicles, yeah, or the internal combustion engines for that matter. Yeah, so disruptive innovation is something where you are disrupting certain things. Okay, traditionally we've been using IC engines. Electric vehicles are disrupting the IC engine technology. Okay, and maybe fuel cell may disrupt the electric vehicle technology, maybe. Okay, so not necessarily all the disruptive technologies or all these technology, all the disruptive innovations may actually realize the market potential. Yeah, so the need or the pull from the market, rather it's very less, but the technological complexities or advancements are high here in terms of disruptive innovation. Okay, so let's take about radical innovation. So radical innovation is something very new. Okay, this innovation is something very new. It has both market pull, and it also has, you know, the technical advancements. Okay, so this is radical innovation. Okay, for example, ESP in car, electronic stability function in a car, where it adds a lot of stability function to your car. Okay, it's a radically, it's a new innovation. Okay, and if you add a certain functionalities on top of ESP, then it comes to the incremental innovation. Okay, now the last one is architectural innovation. In architectural innovation, you have high market pull, but you don't need complex technology, but rather you need a very simple or lower grade of technology. Okay, for example, GPS in car. So this architectural is, you have same product, same technology, but the market is different. Okay, you can also think about the example which I quoted before, automotive spark plugs and lighters for LPG stoves, right? It's an architectural innovation. You have this usage in some other area, use it in your area. Okay. So these are the various levels of innovation, and it's also important as a design engineer to see the product what you are working on falls under which category, and you get this holistic view. Okay. All right. So to sum up, the 4 stages of innovation for the concept generation is incremental innovation, disruptive innovation, radical innovation, and architectural innovation. So these are the 4 types of innovation which we saw with example. So innovation for concept generation, let's just take some example, right? So you pick idea from somewhere. Say for example, in 1900s, how air conditioner was used to solve the humidity in a printing plant. Yeah, actually air conditioner was not invented directly to solve to reduce to control the humidity and to control the temperature in the room. No, I mean, at least uh, the usage was not like what it is right now, right? We have the air conditioners everywhere, starting from home to office, so on and so forth, in theaters. Yeah, but the main intention of this air conditioner was to solve the humidity problem, or to control the humidity in a printing plant, because in a printing plant, if you have a lot of humidity, it is going to spoil the process, right? And then they bought this idea and patented it for usage in car. So that's how the car air conditioner got invented, from the printing plant you know uh, uh, air conditioner. Okay. Now the first thing is you understand the customer need. Okay. So you can ask your customer directly, yeah, how I can improve the product, how I can improve my product to meet your expectation. So they will give a lot of ideas. Yeah, this is also a brainstorming process. You also include the customer in your brainstorming discussion. So they are going to give a lot of ideas to you. Okay, but again, have that. It may also not be cost effective. Okay, but try to get the ideas from the customer. Most likely these ideas are so much of value addition to your to your concept. Okay, so typically it could be the case that where you are giving a product to the customer, and customer is asking for more features on the particular product. Okay, so make it so they may ask for a better quality, they may ask for a cheaper cost. So you can think about any of these features, or different aesthetics for that matter, any of the design considerations. Yeah, so you could also get the innovation or generate the new concept from the customers also. Okay. So what you have to do is you have to observe the customer. It's very important. Yeah. So there are always two views for a product. Any product has two views. Yeah. One is the developer view. The developer view of how the product he or she thinks has to be used. Okay, this is developer view. The other view is the customer view, which is very important. Most likely these both views are not same. For example, you design the product to be used in a particular way, but the customer uses in a different way. Okay, very simple. So you need to try and visualize from customer standpoint. Okay, for the innovation, how customer is going to use your product. So when you are trying to innovate, you should not think how you are going to use the product. Okay, how the subject matter expert or anyone for that matter is going to use the product, but rather you should think how the customer is going to use the product, because that's where the product is going to be used. This is very important for concept generation. Okay, now once you think about it, okay, are you finding new ways? Let's take a very simple example. You are designing a gear system a normal mechanical car, right? A manual gear system car. Now, as an expert or as an engineer, while changing the gear, okay, that you have to press the clutch fully. Okay, so this is very clear to you because you know how the product has to function. But it may not be the same thing with the customer. The customer may not fully press the clutch, and he or she may still try to change the gear. Okay, now that's where the automated gears, all ideas of automated gears or automated automatic gear came into picture, right? So this is one example how you perceive how the customer use the product, and from there you develop the product. Okay, and use difficulties and complaints. Whatever product you have, you are delivering it to the customer, try to understand the difficulties and complaints. There is a lot of innovation or a lot of concept from there. Okay, now you take any product for that matter. Okay, let's take an example of a gas lighter. You have to press. Okay, now a traditional gas lighter where you have to press it. Yeah, for example, now most of the people say for example using the gas lighters are finding it difficult to press it. Maybe it requires a larger force to press it. Possibly people are old, or people are having some arthritis or some problems certainly, which restricts their usage of the gas lighters, right? Now because they are not able to use it, we can think about automatic lighters. The moment you just switch on the knob, the gas automatically or the burner automatically switches on, and you see the flame. So this is an example again, just to see the pain point of people and working on it. That's a concept, or that's also an innovation. Combine and make something new. So here you combine a lot of ideas, okay, or a lot of inputs from them, and make something new. Get some A inputs and B input and try to make C. Very simple. Okay. Social networking. I mean, it's not it's I would call as a intangible in this list, because you have to talk to a lot of people. You have to network with people, and then you kind of generate a lot of ideas. Okay. So these are some of the ways through which you kind of generate the concept, or you innovate for the concept generation. Yeah. Okay. One important step in the design process is also to understand the Kano model. Kano model is very important in understanding the customer satisfaction level. Okay, whatever product you have designed, it fits in any of these quadrant. Okay, or any of these curves for that matter. Okay, so the satisfaction on y-axis, you have the customer satisfaction from minimum to maximum. Okay, and then you have the features or the implementations for that matter from minimum to maximum level. Okay, so whatever if you are if you want to get into a performance related model, okay, performance related model is something where you balance both your customer satisfaction and your feature implementation. Okay, yeah. So as you move across this performance related curve, you see that it is linearly varying with respect to the customer satisfaction. Okay, so the customer is neither so happy or not sad. I mean, yeah, so with respect to the product implementation, so the customer satisfaction is also pretty okay. Now, you have certain features which is not implemented. Okay, if the certain features are not implemented, your customer satisfactions are always low. There are certain features which by default customer always expects. Okay, so if you are at certain non-implemented feature, you are at a fag end of the customer satisfaction and is not going to give you the business. Yeah, you are not going to get into the next innovation loop. Okay, on contrary, yeah, you can also have minimum amount of customer satisfaction, or for in this curve you can have a maximum amount of customer satisfaction with features fully implemented. Okay, so this is also a place where the customer satisfaction is very important. So if you are somewhere in the basic curve, okay, we better operate here. Yeah, but again the customer satisfaction is not much. Okay, so that's the reason you can either operate here or you can operate in this curve. So in this curve we place the customer satisfaction and the feature implementation or the product implementation for that matter, which is linear. Okay, so both increases. You increase the product functionalities or increase any particular features in the product, your customer satisfaction also goes up. Okay, and you add something extra in the features. I mean, yeah, and certainly the customers are already excited in terms of the features whatever you are going to add. Say for example, if you are here, the customer satisfaction is already high. Yeah, and then as you keep increasing the innovation or the features in the product, the customer satisfaction is going to peak. Yeah, so this will be most likely cost, or the product cost will be more, or the cycle cost will be more. Yeah, operating here would lead to a basic fault, or the customer is not so happy about the product features. Yeah, so customer is not satisfied. So somewhere we have to operate in a performance related area. So try to just understand the Kano model holistically in terms of how you can operate with respect to the customer satisfaction and the product implementation. Okay.